Good day, everyone. We are going to talk about theory of equations, the remainder theorem, and logarithms. So let's start with remainder theorem. What is a remainder theorem? If a polynomial is divided by x minus r, the remainder is equal to the value of the polynomial when r is substituted for x, where r is any numerical coefficients. It is given by this equation f as a function of x. So we can understand it further when we have an example. For number 1, we have 5x cubed minus 2x squared plus 8x plus 15 all over x minus 3. So our solution, equating our divisor to 0 to have the equation or to have the value for x, which is x is equal to 3. Then substituting this value of x to our dividend, which is equal to 5x cubed minus 2x squared plus 8x plus 15, we will have this equation substituting all x by 3. So we have this, then our answer is 156. Therefore, the remainder is 156. Next, for our example number 2, x raised to 4 plus 7x cubed minus 3x squared plus 10x minus 11 all over x minus 5. So our solution, again, equating our divisor to 0, then we can have the value of x, which is equal to 5. Then substituting this value of x to our dividend, we have this. Then computing it, we can have a value of our remainder, which is equal to 1464. For our last example, we have x raised to 5 minus 4x cubed minus 2x squared plus 9x plus 17 all over x plus 7. So our solution will be equating our divisor to 0, then we have the value for x, which is equal to negative 7. So substituting this to our dividend, substituting this value, so we have this equation. So you must be careful with the sign because it varies, especially when we have exponents. So our answer is negative 16,608. So that is our remainder. So try to solve these equations. Go and pause this video and answer these three problems. So we have in remainder theorem, we have our exemption. So we have this note. Remainder theorem is only applicable if the divisor is first degree. If not, use long division. So in our examples and in this problem, all of that has a linear divisor. So like this, x minus 2. If you have a quadratic equation as a divisor or any divisor which has higher exponent, higher than 1 exponents, you have to use the long division because remainder theorem is not applicable in cases like that. So let's move on to logarithms. So what is a logarithm? So, a quantity representing the power to which a fixed number, which is the base, must be raised to produce a given number. So, for example, if 2 raised to 3 or 2 cubed is equal to 8, then the logarithm of that is equal to or given by this equation log with the base of 2, log of 8 with the base of 2, is equal to 3. So that's the meaning of this definition. So a quantity representing the power to which a fixed number, which is the base, must be raised to produce a given number. So that's it. So if that's the case, in general, if n is equal to b raised to x, then log of n with the base of b is equal to its exponent, which is x. So that's the same in this kind of equation. So as you can see, the base will be, or the whole number here will be the base in the logarithm equation. So next is the laws of logarithm. So first is the product rule of the logarithm, which is the log of a product of m and n is equal to the sum of its logarithm. So take note that m and n here are just variables. So next is the quotient rule of a logarithm, which is equal to the difference of the logarithms. Next is the power rule, which is the log of m raised to n is equal to n, which is the power, times the log of m. And for our last law, the nth root of a number is equal to the log of m raised to 1 over n, which falls under the power rule. So it is equal to 1 over n times the log of m. So we can understand it further if we have an example. So for number 1, 7 raised to x is equal to 360. We have to find the value of x using the law of logarithm. So taking the logarithm of both sides, then following the law of logarithm, and it is under the power rule. So we can get this equation. Then our goal is to find the value of x. So dividing both sides by log of 7, x now is equal to 3.025. So for our next example, 5 raised to 1 over x is equal to 15.71. So again, taking the logarithm of both sides, then following the power rule in this case, we can get this equation. Then simplifying and getting the value of x, we arrive to this answer, which is x is equal to 0.584. So you can double check it with your calculator. And next example, 8 raised to x times 5 raised to 3x minus 2 is equal to 27. So in this kind of problem, again, we take the logarithm of both sides, then simplifying and following the rules of the law of logarithm, we get this equation. Then simplifying further, we have this x times log of 8 plus 3x log of 5, because we distribute these terms, minus 2 times log of 5 is equal to log of 27. Then grouping like terms, we transpose this term to the other side, then simplifying, adding these two terms since they have the same coefficient of x, Then it is equal to 4x times log of 8 plus log of 5 is equal to log of 27 plus 2 log of 5. So in this equation, it is obvious that we can get the value of x. So dividing both sides by log of 8 plus log of 5, then we can arrive to this answer, which is x is equal to 0.44 or 0.442. So I think it is clear for you to answer this problem. So try to solve this. I'm sorry, it is number 4 problem. So you are given this equation, 2x times 2 raised to x, 2 raised to x times 5 raised to y is equal to 21, and 3 raised to x times 7 raised to y is equal to 35. So the answer would be x is equal to negative 0.48. Then for y, the answer is, or the value is 2.099 or 2.10. So you can try solving this problem. So that's it for this topic. And thank you for watching, and please subscribe to my channel. And to the last problem for the logarithm, if you find it difficult to find the answer, please leave a comment and I will post the right solution and the answer for that problem. Thank you.